All right, the next type of factoring that we've got to look at is called factoring difference of squares. So before we get into that, let's just recall how to multiply two binomials. So multiplying two binomials we did with what we call the box method. So I'm going to put x minus 3 here and x plus 3 here. So x times x is x squared. X times 3 is 3x. And negative 3 times x is negative 3x. And negative 3 times 3 is negative 9. And remember, when combining like terms here, so negative 3x plus 3x, these will cancel. And that result would be x squared minus 9. All right, and let's look at this next one. All right, I have 2x plus 5 and 2x minus 5. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 5 times 2x is 10x. And 5 times negative 5 is negative 25. Again, combining like terms, 10x minus 10x will go away. And I'm left with 4x squared minus 25. So if you would notice these, both of these, their middle terms canceled out. Okay? And this is kind of where difference of squares comes in. So I'm left with an answer of x squared minus 9. 9 is a perfect square, and so is x squared. Over here, I have 4x squared minus 25. 4 is a perfect square, so is 25. So I'm going to make a list right up here at the top of my perfect squares. So starting with 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and then they continue. Okay, so when we are factoring difference of squares, these are the numbers that you are looking for. Okay, so two things have to happen. All right, in order to be a perfect square, so looking here at this problem, I have x squared minus 25. Okay, x squared is a perfect square. 25 is also a perfect square. The other thing that has to happen is it must be a difference, meaning you must have a minus sign. So when I do that, what you are going to do, it is going to factor into two binomials. So I'm going to go ahead and do that. You are going to do the square root of both of these values. The square root of x squared just gets rid of the square. It will be x and x. The square root of 25 is 5. And then I will have a plus and a minus. So if you would look back up here at the first example, I had x minus 3 and x plus 3. The minus 3 and the plus 3 are what canceled to give me just the two things as my answer. All right, so the next example, x squared minus 9. Square root of x squared is x and x. Square root of 9 is 3 and negative 3. All right, and then let's take a look at this one. So hopefully when you look at that, you realize 3 is not a perfect square. It is not in that list, and neither is 75. So we are going to look for a GCF first. Okay. So I'm going to put it into my box and figure out what they both have in common. So I know I can divide both of these by 3. And this one has an x squared, but this one does not have an x at all. So 3 will be my only common factor here. So up here I will be left with x squared minus 25. Just 25 times 3, give me the 75. So I'm going to rewrite it like this. And then now I have a difference of squares left. So I will square root and square root. Square root of x squared is x and x. Square root of 25, I'll get a positive 5 and a negative 5. All right, let's take a look at a few more examples. All right, these are both perfect squares. So square root of x squared is x and x. Square root of 64 is 8 and 8. I'll get a plus and a minus. All right, 16 and 9 are both perfect squares. So we have an extra thing, a number here. So when I square root 16, I have 4 and 4, but I got to break that h squared up to h and h. Square root the 9 to 3 and 3 with a plus and a minus. All right, and then here, 121 and 4, they are also perfect squares. So square root of 121 is 11. Square root of 4 is 2. That b squared needs to be split to b and b, plus and minus. All right, when you look at this one, 27 and 3, not a perfect square. So we need to look for that GCF. All right, so I can divide these both by 3. And then this one has a g to the third, and this one has a g to the first. So that g to the first will come out. So to get this 27 here, I need a 9 up on top. 9 times 3 is 27. And to get g to the third, that's already a g to the first. I need g to the second. And then 3g to the first and 3g to the first. Well, if those are the same, then this just is a positive. It'll be a negative 1, excuse me. So that'll give me 3g to the first times 9g squared minus 1. All right, and now I'm going to square root each of these. So square root of 9 is 3. To get that g squared, I need a g and a g. Square root of 1 is just 1 with a plus and a minus. All right, on the next one, they're both perfect squares. There's no GCF here. So square root of b squared is b and b. Square root of 16, 4 and 4, plus, minus. And then the last one is 625. Now, square root of x squared is x and x. And the square root of 625 is 25. Plus and minus.